A company produces two products, A and B. Product A requires 2 hours of labor and 3 hour materials, while product B requires 3 hours of labor and 2 units of raw materials. And the company has 120 hours of labor and 90 units of raw material available. And the profit per unit of product A is $5. And the profit per unit of product B is $4. And the company wants to maximize profit. In this video, I'm going to formulate the problem as an integer programming problem. So we are given that problem there. So for us to formulate an integer programming problem, we follow the following steps. Number one, we identify the decision variables. Number two, we define the objective function. Number three, we formulate the constraints. And number four, and the non-negativity and integer constraints. Then we go on and write the complete integer programming problem. So those are the steps that we have to follow. So I'll start by step number one, identifying the decision variables. The decision variables there will be how many of each A or B should be made. So that will be our variable. So we have number of products of item A. So I will denote that by a variable x1. Number of products of item B, we will denote it by x2. So those are our decision variables, the one that we need to change there so that we maximize our profit. Then the next step is to now go on and define our objective function. So for our objective function, we are looking at this part here. The company wants to maximize its profit. And for the profit, we are saying that product A has a profit of $5. This is the profit for each type of product A. But we are making X1 product A items. So the profit from product A items will be 5 times X1. Then we go on and look at the profit for each product B item. It's a 4. So the total profit from product B items will be 4 times the number that we are making, which is X2. So it will be 4x2. So in terms of the total profit, we'll be adding the profit from product A and then from product B. So what we have there is we need to maximize Z, which is equals to 5x1 plus 4x2. So that's our objective function there. So after looking at our objective function, we go on and look at the following. We are having for product A there, it requires 2 hours of labor and 3 units of raw material. I find it convenient to put this information in a table before I go on and write the constraints. So I will have a table and we have product A, then product B. So we have the labor and the raw material that is required. So for product A there, from the highlighted parts, we are saying it requires 2 hours and it requires 3 units of raw material. I now move on to the second one there, the product B. It requires 3 hours of labor and 2 units of raw material. So I can write the 3 on the row where we have the labor and the 2 on the row where we have the material. And then go on to the next step. We look at this information. The company has 120 hours of labor. It's a limitation there. And we also have a limit there, which is saying that they have 90 units of raw material available. What it is saying there is the company can have 120, but it cannot exceed the 120 there. So those are our constraints. So we are saying our constraints are the labor hours and the raw material available. So we can go on and fit that into our table. For the row where we have the labor, we put the 120. And for the row where we have the material, we put our limit there, which is a 90. So after writing our information in a table, I can now go on to write our constraints there. So for our constraints, it will be for the product A, we are saying it's X1, product B, we are saying it's X2. So when we add the 2 multiplied by X1, then 3 multiplied by X2, it should not exceed 120. Not exceeding 120, so we'll be saying 2x1 plus 3x2 less than or equals to 120. Then when we look at the row where we have the material there, the product A is the x1, product B is the x2. So when you say 3x1 plus 2x2, it should not exceed 90. So our constraint there is 3x1 plus 2x2 is less than or equals to 90. We then go on and look at the non-negativity constraint. So for the non-negativity constraint, we don't want the number of things here to be negative. So we said that x1 and x2 are greater than or equals to 0. And in this case, we are looking at an integer programming problem. For integer programming problems, we don't want our solution to have values which are not integers. So we'd have to set the constraint that x1 and x2 are integers. So our complete integer programming problem will be maximize z is equals to 5x1 plus 4x2 subject to these constraints here.